Hello everyone, welcome back. My name is Mr. Cobalt, and in this video we're going to be going over how do liquids boil. In other words, how do bubbles form in the liquids? So let's get into this. Okay, so what I have here on the board are some pictures of liquids. Now, we talked about how vaporization and condensation work at the surface of a liquid, but here we're going to look at in the liquid itself. Like, how do bubbles form in liquid? So, as we said, the water molecules, we're imagining that these are water molecules. Every circle is a water molecule. And so the water molecules are still moving around. They still have a certain amount of energy and speed to them. And so you can see here that we have different uh, molecules moving at different speeds. Again, remember, this is an average. So there's an average kinetic energy. There's a certain temperature with the solution. We're imagining that this is a liquid here. And so different molecules of water are moving at different speeds with different velocities, but there is an average, and temperature measures the average. So keeping in mind that some water molecules are moving faster than other water molecules, some of them may be moving fast enough so that when they collide with other molecules, they kind of create a space, right, in the liquid. So you can kind of see here that this water molecule here is hitting these two over here, and that's going to cause a force and pressure, and so that's going to cause them to kind of move out and create more space. And so here you can kind of see that there is a bubble kind of in the liquid, right? Now, in this case here, the bubble's not going to last very long because the pressure on the outside is greater, and so that bubble's not going to last long in the liquid, right? However, what's going to happen is as you provide heat, more of the molecules of water are going to have more or higher energy, higher speed, and so therefore the collisions are going to become greater. Now, what's going to happen is you got to kind of think of the bubble here forming inside the liquid as a surface, right? So you're creating a kind of shell of water that's kind of creating a circular surface. This is no different than the surface we were talking about before on the top of the liquid. So just to kind of talk about this a little bit, right? So here I have a wine glass. This is the best glass I could find. So you can see the surface of the water, right? So what we are talking about is inside the liquid here, the liquid water. So what's happening in the liquid water is that you have these tiny bubbles that might form in the water due to the movement of the water molecules. And so it's going to create a small bubble. And so that bubble has a surface to it. And so just like the surface on the top here, so we have this surface of water on the top, right? And so there's evaporation occurring on the top. And so water molecules are evaporating. The water molecules that have enough speed, enough momentum, enough kinetic energy to break free from the attractive forces at the surface here are gonna break free and then become vapor, right? So the exact same thing happens inside the liquid as well. So instead of having a flat surface at the top, you have a circular or spherical surface inside the water. And so just like at the surface, you can have evaporation and condensation happening in equilibrium, you can also create that same phenomenon inside the water when you create a bubble, right? So I just wanted to kind of bring that to bear. So what we're creating here inside the liquid is a bubble that has a surface. So some of the molecules of water at the surface of the bubble can evaporate and become vapor if they have enough energy to break free from the attractive forces of the surrounding water molecules. So at room temperature, this might be happening microscopically, but the bubbles are so small and the bubbles aren't going to last very long. However, if I heat up the liquid, right, if I put my pot on the stove and start adding heat to it, I can increase the temperature of the liquid, increase the average kinetic energy, and so more molecules. I'll have a higher percentage of water molecules that will now have enough energy to break free from the surface of the bubble that's forming. And so if we move to this picture here, you can see now I have a larger surface, right? The bubble has gotten bigger. More water molecules are able to break free and bounce around inside the bubble, right? So again, just like at the surface, right? Just like at the surface of my glass here, I could have water molecules that will break free. But again, if I close the system, right, by putting my hand on, then those water molecules cannot escape, and so they'll bounce around inside the glass, and then they can hit the surface again. And if they hit the surface correctly, or I shouldn't say correctly, but in the right way, they can be reabsorbed into the liquid and become in the liquid phase again, right? So as more water molecules evaporate, you can also have water molecules collide with the surface again and be reabsorbed into the liquid. And the exact same thing is happening inside the liquid in the bubble, right? So here you have the surface of the liquid. Some water molecules on the surface of the liquid can have enough energy to break free and become vapor. And then as they travel across the space of the bubble, they can then hit the surface with a certain amount of force, causing space to be produced, right? So the bubble can get bigger. Some water molecules can be reabsorbed into the liquid phase. Some of the water molecules on the surface can then break free if they have enough energy from the surface and become vapor. So you've got this condensation process and this evaporation process happening at the same time inside the bubble, just like you had at the surface of your liquid in my glass that I was just showing you. So what's happening now is that as more and more water molecules are breaking free, more water molecules can bounce around inside the bubble, collide with the surface, pushing the surface out, and then ricochet off, right? So if they have too much energy, the attractive forces aren't going to be strong enough, so they'll bounce right off and go across the other way, bounce. And so again, it's a process between evaporation and condensation happening inside the bubble. And so as you're heating it up, more and more molecules can gain that amount of energy to break free from the surface and create more water vapor. And therefore, the water vapor inside the bubble can increase the vapor pressure. So we talked about vapor pressure happening inside, right? So if I cover my glass, right, if the water vapor builds up, the condensation process increases, right? As I get more and more molecules in the vapor phase, more molecules in the vapor phase will collide with the surface and be reabsorbed into the water phase, the liquid phase, and that's condensation. But at the same time, you have the process of evaporation where the water molecules are breaking free from the surface, breaking free from the attractive forces. And so you can get, at some point, the rates of evaporation and the rate of condensation will be equal and you get an equilibrium, right? So if I take my hand off, you can create an equilibrium, but then you got to create it with the, how should I say? You won't create an equilibrium, but air pressure is involved. So let's talk about that with regard to the bubble, with boiling, right? So because you have water vapor inside, because the water vapor and the bouncing around and the collisions of the water molecules in the vapor phase to the surface of the water of the bubble, the surface of the bubble, you have a vapor pressure, right? So here we're talking about a vapor pressure internally in the liquid, not a vapor pressure above the surface of the liquid like we was talking about before, right? But they are very much related. So here you have a bubble that's forming due to the water vapor that's bouncing around and the pressure of the vapor inside the bubble. Okay, so what's going to, oh, excuse me, I knocked something over. So let's look at the three different situations, right? So if the water vapor, if the vapor pressure of the inside the water, right, the water inside the bubble here, right, is less than the exterior pressure. Now, what is the exterior pressure? The exterior pressure is the pressure due to the water molecules surrounding the bubble. So there's a weight due to the water, right? More water on top of the bubble is more pressure, right? As if you swim down to the bottom of a pool, the farther you get down in the pool, the more pressure the water you feel. It's the same thing with bubbles. So the bubbles are feeling a certain exterior pressure due to the water itself, but it's also due to the exterior pressure of the atmosphere, right? So the atmosphere is also pushing down on us. It's pushing down on the water, and that atmospheric pressure is also being translated into the water to the bubble, right? So if the water vapor pressure inside the bubble in the liquid is less than the exterior pressure, then what's going to happen is that the bubble will form, but it will collapse on itself. It's not going to last long enough. It's not going to become large enough to then stay and rise to the surface of the liquid, right? So, but if the water vapor pressure, right, so the vapor pressure inside the bubble, if that is greater than or even equal to the exterior, right? I hope you can see my arrows. So in this one, I have red arrows that are small, representing the small vapor pressure with respect to the exterior pressure. So I have these larger blue arrows. I don't know if you could see them here, right? So the larger blue arrows are pushing down on the bubble, so therefore it will collapse. Here, I have large red arrows representing the vapor pressure inside the bubble, and then the smaller blue arrows are the exterior pressure. And so because the pressure inside the bubble is larger, then that means it can grow and it will stay. It won't collapse on itself. Same thing with if it's equal. So if the arrows, the red and the blue arrows are equal to each other, then the bubble will stay and it won't collapse on itself, right? So what's going to happen is if you raise the temperature enough, right? Remember, higher temperature means higher vapor pressure, right? So as the temperature increases, right, the pressure, more molecules will break free from the surrounding surface, right, of the bubble. More molecules will be in the vapor phase, and therefore more vapor pressure inside the bubble. When you reach a certain temperature, the vapor pressure inside the bubble will be equal to the vapor pressure outside of the bubble, the exterior pressure, the atmospheric pressure. So at that point, the bubble will stay, and then what will happen is it'll grow, and then the bubble, the density of the bubble, right, will be less than the density of the water, right? And so then the bubble can rise to the surface of the liquid and then break at the top, releasing that vapor that was in the bubble. And that is what we call boiling. So when you have the temperature, right, the temperature of boiling is referred to as the boiling point of water, right, or the boiling point of the liquid, whatever liquid we're talking about. And so in this case here, we can define the boiling point of water as the point or the temperature at which the vapor pressure in the liquid, right, of the bubble is equal to the vapor pressure outside, right, above the surface, the vapor pressure, the atmospheric pressure, right? So the vapor pressure inside is equal to the vapor pressure outside. And so that is how boiling occurs. So that's it for this video. In my next video, I will be talking about how the boiling point temperature will change in response to changes to the exterior pressure. So thanks for joining me in this video. I appreciate you joining me. If you like this video, then please hit the like button, subscribe to my channel, comment in the bottom below. Let me know what you think. I'd love to hear from you. Thanks for joining me and have a great day.